now that we've explored certificate revocation, we need to get an understanding of what certificate expiration is and how it impacts us. So we've got a certificate, we've applied it to the website in our scenario, and we've managed to operate it for the full lifespan that that certificate was provisioned for. So what happens when that lifespan comes to an end? Well, one of two things can happen. We can either go and acquire a new certificate from a certificate authority, or we can continue to operate with that expired certificate on the website. The best choice and the correct choice here really is to go out and acquire a new certificate and then apply it to the website. If we don't do that, then what we're going to experience is whenever a user browses to our website, instead of seeing the normal website that loads and it's nice and secure, they will get a warning that comes up on the screen that says, look, the certificate for this website has expired. Are you sure you want to continue to trust this website and therefore want to continue going forward and seeing this website? As we can all guess, that's not the best user experience. It's not very friendly, and it throws up a warning in their face saying danger. So we really don't want to be doing that. In many scenarios where that happens on the internet, on websites, it's usually because the website administrator is vacant or left, and the website no longer really is being maintained. So a good sign of a website being maintained is a continuation of a valid certificate on it. As you can see on the slide in front of us now, we've got an example of a certificate that has expired. This is the kind of message we're going to see that comes up. It's going to highlight the website that the certificate was made for. It's going to highlight the date that it was expired on, and it's going to give you the error code of SEC error expired issuer certificate. And what that means is obviously the certificate has expired. We shouldn't be trusting it. You can click a little link down the bottom that often says you can add an exception and allow yourself to continue forward, or click advanced and proceed. Either way, it's probably not the best user experience, and we want to be getting that replaced as soon as possible. Now, what's the difference of using different technologies with SSL certificates that we get from our certificate authorities? Well, there's two main components of technologies that we can explore. The first is, do different internet browsers react differently to an SSL certificate and PKI authorities? You know, examples of browsers include Chrome and Edge and Firefox and Safari. They're our most common ones. And when we get onto a website that has an SSL certificate that's being promoted to say, look, we're nice and secure, are there any major differences? The reality is there isn't. If anything, there might just be a little bit of difference in regards to how things are shown. So that padlock in the top left corner beside the URL, it might be green or it might be blue depending on what browser you use and depending on the type of SSL certificate being deployed. The reality is those browsers are going to be pretty good, and as long as they're up to date, we shouldn't really see any issues. If the browsers are no longer up to date, it's possible that the certificate authorities inside of them may have then also fallen out of date, and therefore they need updated in order for you to trust newer certificates. Do different web server technologies as well have an impact on SSL certificates? Now, when we look at SSL certificates, we have to understand that it's a universal security system. We want to have a single format of how to secure a website across the internet, and that comes in the form of an SSL certificate. It comes in, this website has been proven to be owned by X, and here's a certificate that proves that we've checked this, and as a result of that certificate, it's been created with this type of encryption, and therefore you can utilize that encryption when you access the website, so your communication between yourself and that website is then encrypted. Now that universal approach, which is built by different authorities on the internet, CASB comes to mind, is general, and therefore all of the different website technologies out there that help you host and build a website really want to be adopting that and applying that to enable the websites that they host to be as secure as possible. Instead of having lots of different little standards, it's better to have one main core standard that everyone adheres to, and therefore these technologies are usually built to those and keep those in mind as they're operating and being maintained. So impacts, not really. There shouldn't be any kind of significant impact. If anything, you may find that one type of server may like a certain encryption over another one, but nevertheless, the encryptions are quite standard, and that kind of difference probably won't be around for very long if it is there. They should all be accepting pretty much the same encryptions. So let's move on to how we can check if an SSL certificate's working. There's a couple of ways of doing it. I mean, first of all, we can start with manual checks. We can go to the website, we can type in the website URL, and we can type HTTP at the start and then the website address and hit return. If it returns just using HTTP, then that communication says that it's allowed to operate in plain text. There's no SSL certificate on that attempt. It may be that the website also allows HTTPS communication. So if we type HTTPS and then the website address and hit return, and if it comes back in HTTPS without an error, then it also means that that website's operating over HTTPS, which is using an SSL certificate that was provisioned by a PKI authority. Now, the best approach is to disable HTTP and go with HTTPS. That's the most common approach. Some websites may also go, well, you've entered HTTP, let's redirect you and send you over to HTTPS. And that's also acceptable. We can, once we're on that website, if it's operating over HTTPS, we can then also view the certificate in the browser. I'll show you how to do that in a minute. And the third option is we can use a more technical approach by using the software called Nmap and one of its scripts where it will show you how to query the website address and it'll pull back the certificate for you and show you the details of the certificate. So they're the manual checks. I've put Nmap as a manual check because you still have to open up a terminal on the likes of Linux and you need to enter the commands, so you're manually doing it. There are some online solutions as well. So we've got SSL Labs and we've got Mozilla Observatory. Both of these websites, if you go to them, will allow you to just simply enter a website address and click go, and it will go away and it will find the details that you need to be able to check that something works and has the SSL certificates. SSL Labs is particularly good because what it will also do is tell you if all of the appropriate ciphers and encryptions that are available on that website are actually still up to date. So if something's been known as being breached or weak, then it'll flag it up and say, like, you really should be disabling this cipher or this encryption on the website to make sure that when you are using TLS and SSL, that the communication is still maintaining that level of security. I've just mentioned that one of the things I would do is show you how to check that you've deployed an SSL certificate correctly in a manual way. So to do that, I've got the Internet Archive open on a tab in Google Chrome, and we can see in the URL that we have HTTPS. So we know that we've got an SSL certificate that's been deployed, we know that it's been provisioned, and that it's live. So if we also take off the S and make it a HTTP connection, it then redirects us back to the HTTPS, as we can see, which was one of the recommendations that I put forward. So the next thing we can do is click on the padlock, and we can see in the drop-down menu that we have a certificate option. So if we click on certificate, it then pops up the certificate details in the certificate window. And we can see that the certificates for archive.org, we can see that it's got a issued on and an expiration date. We can see that it was issued by the PKI Certificate Authority of GoDaddy. And we can get more details if we click on the details tab, such as the serial number. We can get the validity dates, not before, not after. We can get the information about who issued it, and more information as we explore. So that is how you can see if the certificate is live. A good example might be when you've got a certificate live on the website and you need to check that you've updated it correctly for a new certificate, so with the old one doesn't expire and therefore your website ends up with an expired certificate on it. One of the key checks there would be to know what the serial number of the certificate is and be able to check it in the field value here. Another good check would be the not before and not after fields. So if we know that we've just generated a new certificate today which is the 29th of December 2021, we would know that the certificate wouldn't really have a date of prior to that, so not before. For example, it wouldn't be 2019 in this case. If it was 2019, then we would assume that we've still got the old certificate running and the new certificate hasn't taken over yet. So maybe our deployment hasn't quite gone right. So last slide, and I'll finish it here. If it all goes wrong, you've somehow messed up the SSL certificate. You've somehow provisioned an SSL certificate that doesn't quite match the website. You've put the wrong URL in, or something weird's just happened in general, and it just isn't working. What do you actually do? Well, the simplest solution is just start over. Generate a new certificate signing request, or CSR. Get it signed by the Public Certificate Authority, or CA, and then apply it to your website. And that's the best thing to do. So the only time you shouldn't really do that is maybe if it's costing a lot of money. Maybe then at that point approach your certificate authority provider and see what they can do. But generally, if you've generated a wrong certificate, you're going to have to go back and generate a new one and then do that process again and then apply it. It should be roughly okay though. I mean, it's quite a straightforward process once you get the hang of it. Um, and when you get onto the likes of Let's Encrypt, if you need to generate a new certificate, it's very straightforward and easy. You just follow the website's guide and you can use the likes of certbot technology and it will take you through that nice and simple. So let's explore how we can make a certificate signing request now. That's quite an important thing because that's going to be the core of getting an SSL certificate from a certificate authority. Getting that sent over to a registration authority and getting it signed off and proving who you are. So we'll do that now and we'll leave it there. I'm now going to show you how to create a certificate signing request. It's quite a straightforward process and it is what's required in order to get a public certificate authority to give you a signed certificate that you can then utilize. So for complete transparency, I'm using a Linux-based desktop right now, and therefore I'm going to be using the software called OpenSSL, and we'll be doing this in a terminal. So we'll start by opening up a terminal, and inside this terminal we'll confirm that we have OpenSSL installed. And the easiest way to do that is to just check what version is installed. So I'm typing OpenSSL space version and pressing return. The response I get from the terminal is OpenSSL 1.1.1f, which confirms the version that I have installed, as can be seen right here. Now for the next part, you can either use OpenSSL's man pages or help pages to try and establish the right process to generate a certificate, or you could do a bit of research on the internet and find one of the many examples which are out there. And that's what I've done. So in this text document on the right hand side of the screen, I have an example command on how to generate a certificate using OpenSSL. For appropriate referencing, the above command comes from ssl.com, so the website. So what we'll do is we'll use OpenSSL. We will generate a new key using RSA 2048, and what will be given back is an example.key file and an example.csr file. So if we copy this and drop this into the terminal and then press return, we can start seeing that something's happening in the terminal. So it's wanting to write a new private key, and to do so it's asking us for a passphrase. Now for this example I'm going to use the term password, which is really bad security, so don't use that yourself. It's just simple to remember, simple to use for examples. And then it's asking us to verify it. Okay, so we've confirmed and verified that our passphrase is correct, and it's what we wanted. Now what we're going to be doing is providing information to the certificate signing request about where the certificate's going to be getting used. So it wants you to give that information as it prompts it. So in this case, it wants the country name, a 2-letter code, and it gives AU as an example, which is Australia. So for myself, it would be GB, which would be Great Britain. It's asking for a state or province now, so I'll just put state as this is an example. And for the local name, it's asking for a city, so we'll just put city since it's an example. It then wants the organization's name, so if I just put example, I'll put example limited. And then it's asking for the organizational unit name, so we'll just put IT. And it's asking for the common name, so the server's fully qualified domain name or your name. In this case, we'll use example.com. And an email address, test@example.com. Okay, it's then going to ask for some further information if you want to contribute it, so please enter the following extra attributes to be sent with your certificate request. For the moment, we'll just skip these by pressing return. And what we should see now, if we list the directory, is 2 files, and we can. Those 2 files are example.csr and example.key. Now, if we look at the example.csr, we'll see the following information, which may not make much sense, but it should detail that it is a certificate request. There we go. So we can see that the certificate file itself says begin with certificate request. It has the certificate contents and then states the end of a certificate request. And that's how you create a certificate signing request. If you do, however, find this tutorial quite useful, if you think I've done a reasonably good job of explaining an SSL certificate and the basics of PKI, let me know, drop a comment below. It'll be fantastic to hear from you. I do have further lessons to develop, so there is going to be a lesson 2, a lesson 3, and a lesson 4 from the way that I've broke down PKI. And in those lessons, we will delve a lot further into public key infrastructure and how it works, and more the minor components, which is how you build up a PKI rather than how you just communicate with one. But hopefully this lesson's been a good introduction to that, and good luck.